Hello, welcome back to Elias Explains. This is a follow-up video in regards to my if versus switch comparison video. I got some comments that said that I needed to try some other scenarios. Basically, the comments said my video was a little bit too trivial. I was only showing 2 or 3 branches, and so it was going to be very easy for the compiler to optimize that, and there wasn't going to be much of a difference between if and switch statements. If you want to review the video along with the original post, that is linked down in the video description below me. You can go take a look for yourself. In this update video, what I decided to do was generate kind of a worst case scenario. What I did was I generated 200 strings and a couple of methods that had 200 branches. 201 actually, 200 string matches, and then an else statement or a default statement. I wanted to not only see what the compiler would do when we get to a very large number of strings to compare, I also wanted to see if the outputted code is any different, if there's any more efficiencies, and also benchmark the code. So this time we're using benchmark.net to see if there is any sort of distinguishable difference between if and switch. I will preface this. This is just this code. This is just my scenario that I've come up with. It is arbitrary. It is an example, but in your case, please benchmark your own code before you come and draw your own conclusions. Just because I found results, they do not mean they will apply to your scenario. And I'm also comparing if statements directly against switch statements. If statements, so if else, usually have more complex Boolean logic in them and generally are going to be shorter. And switch statements, you're matching one value. You're doing an equals comparison of some sort. So again, benchmark this against your own code. Don't just take what I'm saying at face value and say, well, Elias has said it, so it must be true. Please benchmark your own code. All right, let's take a look at the code today. So like I said, we have around 200 string values. And what I've done is I've set up 5 tests. I'm testing out basically matching on a string using switch statements, matching on a string using if statements, and then I wanted an extra twist. What if, get it, if, what if? Anyway, what if instead of using if else or else if, we just had if? What would happen in that case? Would that give us any performance boosts? Then I did the same thing. So if we go back up to our benchmarking tool here, I did the same thing with integers. So I created a version that has if, I created a version that has switch, and then I created a version that has if only. Then decided to benchmark the results. Before we get into the benchmarks, which were pretty interesting, let me finish up and explain what I was doing. When I was originally running this, I was just adding all these values to a list, but I was getting a lot of bottlenecking problems and it was influencing the results a lot. So I decided to just simplify things and say, you know what, we're just going to return the value. It'll be a nice simple exercise. The compiler won't do too much to this and it should work. And the results, I think, do speak for themselves. They seem to work pretty well. So let's take a look at the JITted code, shall we? So our first example is the print response function. And once again, we're using sharplab.io, link in the video description. Go check them out, show them some love. They are awesome. As we can see in the print response, so this is the string matching version. You can see our first call is that if our string is null, we branch out to false right away. We don't even mess around in the switch statements. But check this out. Right at the beginning, just as somebody in the comments on the last video that was posted to Reddit pointed out, we're computing the string hash and now we're doing comparisons against integers. Check this out. So we're doing branch then, greater than, less than, doing branch thens, doing lots of branching, branch if equal to. Just all these different branches are happening, which I assume is the compiler basically just saying, you know what? We can do an integer comparison much faster than we can do a string comparison, and that makes sense. So we see that there's an awful lot of code that's been generated. We're branching all over the place. Sometimes it's branch if equal to, it's branch if greater than. So just looking at the code, what I assume is that we're basically branching to a certain range and then narrowing down that range. So I wouldn't be surprised if there's some cool tree-based lookup stuff going on. It's very neat code to read, actually. And then we get into here, and this is where we actually branch, where we do some of our comparisons, actually. So we are still doing a few string comparisons. Very fascinating. So we can see that we're still doing these string comparisons. In fact, most of them are still in here, it looks like. So I'm also, as we're doing this video, I'm actually reading this live just because when I've been going through this, I wasn't totally surprised by by what I was seeing, but it's still pretty fascinating to see, like, we're doing branching based on this hash map, but we're still doing these calls to see, hey, are we equal to the string? And there's a lot of string equality that's happening. So very fascinating to see. So this is the switch statement version. What about the IL for the if statement version? Well, check it out. We have totally different code here. We are doing string equality comparisons all the way down. This genuinely surprised me. I thought the compiler was going to do some sort of optimization here. And again, I'm building on release mode. You can see this here. I'm building on release mode. And we're doing string equality comparisons all the way down the board. So absolutely a fascinating result. So we can see in this case, in this example that I've developed, there is a difference between if statements and switch statements. Quite a big one, in fact. So if we keep going, we see, again, same thing all the way down. Now, what I'm curious to see is if there's any meaningful difference between this version and the print response if only. And again, it doesn't look like there's much of a difference. It looks like they basically compile down to very similar IL. Yeah, that's really all that's noteworthy about this, that there is a big difference between the switch and if statements, at least when we're dealing with strings. What about integers? Let's take a look, shall we? This one is cool. Why is it cool? Because check it out. There is an opcode called switch, which jumps to one of these IL labels. And then we have this IL label here, this branch IL064B. Basically, if we don't match any of these switch statements, we branch right to the end. And then for every single result, all we're doing is adding one and then immediately returning. That is fascinating. So the switch statement that gets generated looks way more efficient than anything that we got from the string values. That's super cool. So we see all the way down, we're just adding one. Otherwise, what is the default value that we actually return? I should double check. You'd think I would prepare these things ahead of time. Let's see what the default value is. There it is. It's just input plus 2. So we add 2, and that's our final version. What about the if version? Check it out. If statements, branch true, branch if not equal, branch if not equal, branch if not equal, branch if not equal. There's branch prediction going on. The if version for integers, again, is just using what you would expect. It's just if, else if, else if, else if. We're just branching all over the place. We're not taking advantage of that built-in switch statement. We're just doing all these branch tests. So one could argue that we're going to run through a lot more code. All right, enough with the delays. What did the benchmarks look like? Well, they shouldn't really come as much of a surprise. Knowing what we know now and seeing the efficient code that got generated, the mean runtime for our default route. So what I did was I set up 2 types of tests. The first one just triggered the default or else route. Basically, I wanted to simulate the worst case scenario. For strings, our mean response time was 8 nanoseconds. When we switched to if statements, that went up to 861 nanoseconds. And then for if only, there must be some form of inefficiency going on there. However, it's only about 2 nanoseconds slower, and our margin of error is 12 nanoseconds. So let's just say it's within the margin of error. If and if only are about the same speed. But we see there is a clear difference in the performance of the code in these two scenarios. Once again, this is specific to my contrived example. This does not mean that that switch statements will always run faster, or that if statements will always run slower. You must test for your own code. Now let's take a look at the int version. No surprises here. The int version runs a lot faster. 2 nanoseconds for the switch version, 186 nanoseconds for the if version, 176 for the if only. Again, the margin of error is around 3.5 nanoseconds. Let's just call these two about the same. There's probably, if you study the IL, a major performance difference between the two, but realistically, it's within the margin of error. Then I wanted to just put this one to bed. I wanted to say, okay, what happens if we have a value that matches? In other words, we have a value that's between 0 and 199, either of the string or of the integer. Those are the conditions that we're going to match on. Would that impact our runtime at all? I was surprised to see, and I guess after reviewing the code, it sort of makes sense, but it was interesting to see that for strings and for the switch statements for ints, it was slower. If our input actually matched, it was slower. Now, our input matched, but it was very far into the domain. I did not run it for the whole domain of values from 0 to 198. It is entirely possible that, depending on the value that we pass in, we could see results that are faster than just the else condition. But as you can see, for if and if only for strings, we were looking at 1,000 nanoseconds, 1,300 nanoseconds, 1,300 nanoseconds for both of these. They're much slower. Much slower. Fascinating, right? And then for int switch versus, the int switch when it matches versus the int switch when it doesn't match, not much of a difference, And again, margin of error, I'd be willing to chalk this up to measurement error. So they perform around the same. And then finally, int if and int if only still run a lot slower. The two versions appear, within-ish the margin of error of each other. So let's just call them equal. But it's real fascinating to see how different code paths, different code styles can lead to vastly different performance. And again, I guess that's my takeaway from all this. Yes, I'm coming up with contrived examples. Yes, they may not be applicable to all scenarios. Yes, this is a horrible example of nobody's going to, hopefully nobody's going to write an if statement that has 200 conditions in it. But again, if you're writing code and you're trying to figure out, is a switch going to be faster? Is an if going to be faster? Benchmark your code. Run it through a service like sharplab.io. Check out the IL that gets generated. Run your code through a tool like .peek. Take a look at what the compiler is spitting out on the other end. At the same time, I would also say, make sure that you've truly narrowed down your performance problems to these truly micro-level optimizations. You should be doing this once you've pulled out all the other go-fast switches that you can possibly find. This is low-level tweaking, and this is why benchmarking is so critical. Without benchmarking, who knows which one would have been slower, which one would have been faster. We can't say for sure. We can sort of eyeball the code, but the benchmark doesn't lie, at least usually. If you construct really bad benchmark code, it can lie. But in this trivial example, the benchmark doesn't lie. So is switch faster? Is if faster? It depends. For this particular case, we found that switch, if we're just going through a list of values and matching on a particular value, just doing kind of the equality matching, switch can be faster than a bunch of if statements. I hope you learned something today. What'd you think of this video? Leave some comments. Leave some comments down below the video. Leave some comments on the C# and .NET subreddit. Lots of fun over there. If you like what you saw, please subscribe, like, share the video, do all the good social media things. This has been Elias Priernan. I'm Elias Priernan. This has been Elias Explains, and I hope to see you in the next video. Take care. Have a wonderful one.